Solve the integro-differential equation by the Laplace transform. So we have derivative, that's why differential equation, and we have integral as well. And if you look at closely, this integral is in fact a convolution of t square convolution and y as a function of t. So we got 2 terms in the left equals negative t, and we have an initial condition. So let's take the Laplace of this equation. So take Laplace transform on the equation. So this is Laplace of y prime minus 1/2, and we know that Laplace of a convolution is just product of Laplace transforms. So Laplace of t squared and Laplace of yt is equal to negative t Laplace of t. So we're gonna find these Laplace transforms in next line. Laplace of y prime, that's the first derivative. By the table, look at the formula list. So we get, yes, Laplace of y, I'm denoting by y. Yes, this uppercase y is Laplace transform of lowercase y minus y0. Okay, that's the initial condition, by the way. Laplace of y prime, from the formula, from the table, we get this minus 1/2 times Laplace of t squared, again from the table we get Tn means 2 factorial 2 over s cube minus Laplace of yt, that's the unknown function, we denote by uppercase y as a function of s, equals negative Laplace of t is like here, so it will be 1 over s squared. Okay, and look at here, this is y and here is y, so we can factor y out. That's the Laplace of lowercase y. Then this y0 is in fact 1, so this value is 1, so negative 1. We can move over to the other side. Okay, and that's negative 1 on the other side, that will be just positive 1 plus 1. I'm going to write 1 plus 1, and we have already negative 1 over s squared. Okay, and here from these two terms we are factoring ys out, and this is 2 from top and bottom also cancel. What is left here? Yes, and here minus 1 over s cubed. Okay, equals, because ys is factored out, 1 minus this 1, negative 1, other side plus 1, 1 minus s squared. Now we need to divide this by this to isolate y. So in the next step, uppercase y, that's the Laplace of lowercase y, is equal to this divided by this. So we can combine these two terms, and we can combine here as well. This is s squared minus 1 over s squared over s squared, that's on the top, divided by this, which is s cubed, yes, s to the 4th minus 1, s to the 4th minus 1 all over s cubed. Okay, I combined these two terms and divided by this. So let's simplify this. This is on the top, we can factor, but let's not do that, because s to the 4th minus 1, this is also difference of two squares, so s squared is squared, so this got s squared plus 1 times s squared minus 1, and we can cancel. So this is s squared minus 1 over s squared, that's on the top. This division into multiplication, we can flip, this s cube goes on the top over s to the 4th minus 1, we can factor, that's s squared plus 1, s squared minus 1. Now we can cancel this s squared minus 1 minus 1. Okay, and we can cancel 2 copies here as well. So that leaves this y, uppercase y, which is Laplace of lowercase y, yes, equals to s over s squared plus 1. Okay, now we take inverse Laplace on both sides. So take inverse Laplace on both sides, then we get inverse Laplace of uppercase y is just lowercase y is a function of t is equal to, and look at the table, this is Laplace of cosine t. So inverse Laplace of s over s square plus 1 is just cosine t. Okay, final.